And we'll get started here. So let me grab class one here. So we looked at a lot of questions last time. This time we're gonna talk about what is the actual structure of a question. You might be like, what is he even talking about? Every problem has the same structure. And this is important so that you know what to expect. The first thing that you always see is what I call the prompt. Okay, the prompt is up here. This it could be an equation, it could be a table, could be a graph, could be words. The next thing is what I call the call to action. This is the thing that we really want to start focusing on, which is what they actually want you to do. And we're going to learn today that sometimes the prompt is unrelated to the call to action. And sometimes you just need the call to action to be able to solve the problems. The rest of this is what's called the answer space. There are two types of answer spaces. There's multiple choice, and then there's what's called free response. Okay. So just a couple of we're not going to solve these, but just a couple of other questions here I'm going to throw up on the screen for you here. Again, the prompt is like the given information. The graph, it's some of these words. The call to action is right here. And this is where we're going to focus today, on the call to action. It's the question, it's the thing that they want you to do. And we're going to learn that for some of these, that there's a lot of unnecessary information in the problems that's going to hopefully help you do better. So right here is the call to action. All the rest of this is the prompt. You can see that the multiple choice space is kind of a lot there, but this is what we're going to focus in on today, what's called the call to action. All right, and every question that you see, every problem you see has one. So the very first test taking strategy that we're going to learn together here is to read the call to action first. Okay, and what does that actually mean? Well, you start by reading the last sentence of the prompt, the last sentence. Okay, so you want to train yourself to go to read the question first. Which of the following is the best interpretation of the number 1.22? How many solutions does this system have? Which of the following expressions is equivalent to the given expression? So sometimes it's easy because it's the only sentence. Sometimes you have to sort of go and look for it, but it is typically the last sentence. Okay. And the reason you do this is, like I said, sometimes there's just extra information that you don't need. After you read it, you decide if you need to read the prompt from the beginning. Like basically decide, like, do I actually need to go back and look at the rest of the problem? Or maybe you can just solve it from there. All right. If you do have to go back to the beginning of the question, you want to read the call to action again. So what this does is it trains your brain. You read this call to action, then you go back to the top and you start reading. Your brain is looking for the answer. It's looking for the information you need. Then you read it one more time to sort of make sure you know that that's the thing you're trying to find. All right.
Okay.
However, if you go back and read the prompt, you may find that there's extra information. There may be distracting words, or you might start thinking about things that are by design. You know, might start talking about ice cream or food, or playing sports or guitar or music. Then you're now thinking about that instead of the actual problem.
All right.
You will find that this approach works best for story/word problems. Okay. And most of the test is story/word problems. Okay. All right. So we're going to look at an example. First example here is a problem, and I'm going to guide you through it here. Let's see if I get away from that. Yeah. I'm going to guide you through it here. We're going to start by reading the call to action first. Okay. The call to action is, what is M when L is 73? What is M when L is 73? They give you an equation. So they're basically saying, solve this equation, do something with this equation. Now, let's read the rest of it. let's go back to the beginning. So we've read the call to action. Let's go back to the beginning right here. One end of a spring is attached to a ceiling. When an object of mass m kilograms is attached to the other end of the spring stretches to a length of L centimeters as shown in the equation above. What is m when L is 73? Is anything that I just read there important to solving this problem?
Uh, eh,
The answer is no. There's nothing here that you need to solve this problem. So why do you think that they put this information in?
uh, maybe I don't know. Maybe if they're trying to, yeah, I don't know.
What did I do last week for every problem that you solved?
Time me.
I'm sorry?
You timed me.
That's right. Time is always working against you. So to read this takes time. It's useless, so it doesn't help you. It distracts you, so it doesn't help you. Time is working against you over and over and over in this test. So all of the strategies that we use are meant to help you solve the problems, but they also reduce your time per question. Right? This problem could be reduced to what is m when L is 73? Here's the equation for L and m. Right? So which is 73? Is 73 the value of L or is it the value of m?
Uh, hey, what?
Is 73 the value of L or is it the value of m?
L.
So we could write 73 equals 24 plus 3.5 m. Okay. So this is an
Oh,
equation that you should be able to solve, meaning you've seen it before, you know how to solve it. You could try the answers.
I
Um,
feel like that's probably what I do, to be honest.
that,
Is
that's fine with
what
me. And for us, you can use a calculator. Um, that's not what we're emphasizing. We're emphasizing this idea of reading the call to action first.
yeah.
So could you solve this for us, please?
Okay. Uh, Probably do.
Yeah, it's a lot better using a calculator instead of your phone. There you go.
Yeah. Uh, are any even right?
It's
I tried all of them. They don't work.
okay. Now, how would you solve this if you couldn't, let's just say it was a free response problem and none of these were here. How would you solve it?
Um, oh, I mean, probably just subtract 24.
Okay, so do that for me. What does
You
that
get
become?
49 equals 3.5 m.
Okay, how do you undo that number in front of m?
Divide by 3.5.
Okay, go ahead and do that for us, please.
You'll get 14 equals m.
Very good.
Bruh.
Okay, okay, so that you just brought up you're like, hey, I tried all these, none of them work. They're unlikely like really, really unlikely ever to be an error on these things. Like, I mean, it's possible, just like it's possible that you get snow in, the valley. Very rare, right? Like it just doesn't happen. Um, so when you tried the answers, you used the calculator, and that's fine. It's totally fine, but you have to be solid at trying the calculator. What comes first with order of operations? Do you multiply or do you add?
Well, like multiply.
Yes. Now, if you added these and then multiplied, you would not get the right result. So that's why you got to be really careful with how you use the calculator. Okay, so we're going to look at another question here, but here's what I want you to do first for me. I want you to identify the call to action. Okay. That's really, really important. That's the skill we're learning today. We want you to be able to quickly figure out, what is it that is the problem actually asking you to do. So here we go. I'm gonna put this problem in front of you. Could you read to me the call to action?
What is P in terms of T?
Yes. What is P in terms of T? There's the equation. Now I know you can go back and read it, but do you think anything in these 3 lines is going to be useful for solving this?
Probably not.
Probably not, but let's read it just to find out. At a store, a coat originally priced at P dollars is on sale for T dollars, and the relationship between P and T is given in the equation above. None of this is useful, but it takes time. The call to action is literally saying to solve for P. Solve for P. Which of these answers correctly solves for P?
Um,
How did you solve the previous problem when there was a number in front of P?
Divide. But I
Okay,
mean, if
so
I divided, wouldn't I just get P equals T? Oh wait. Oh, probably C or D then.
great.
Uh, is it D?
It is D.
Okay.
Good. All right, let's look at another example here. All right, so I want you to identify the call to action for me, please.
No.
What is the call to action?
What is the volume in cubic centimeters of the prism?
Yeah. Have you noticed how in every problem it's the last sentence?
Yeah.
It's really important. You want to train yourself to go right there. Do you know the formula for volume?
I kind of I think so. Isn't you just multiply them all?
Yeah. So give me that. What is the product of those?
Then would be 36 centimeters. Wait,
Okay, so 6
yeah.
times 2 times 3 is 36 centimeters cubed. Very good. Now let's read the rest of it. The figure shows the lengths in centimeters of the edges of a right rectangular prism. The volume V of a right rectangular prism is LWH. So notice they give you the formula there if you didn't know it, where L is the length of the prism, W is the width of the prism, and H is the height of the prism. Just like before, though, all of this is completely useless. We don't need this, but it's there. It's there to distract you. Do not start here, which is like a, stop sign, right? Like we don't want you to read from there. We want you to go right here. We want you to start down here at the bottom always. And then decide. Then decide you need to go back and read the rest. Now, these examples were carefully chosen. They were carefully chosen to illustrate this point. Does every problem work like this? No, but the strategies are meant to help you on more problems than they don't help you on. So this is a good strategy to use. It's the most important one. It saves you the most time by not reading all the extra stuff that you don't need. All right, so here's a new question. The call to action here, is what does 12 represent in the equation? Well, there's the equation, okay? But we don't know anything about the equation. So this time you do unfortunately have to go back and read from the beginning because we just don't know. 12, I don't know, 12. I mean, it's the intercept of this equation, but what does that even mean? So let's go back and look. Salem wants to purchase tickets from a vendor to watch a tennis match. The vendor charges a one-time service fee for processing the purchase of the tickets. The equation T equals 15N plus 12 represents the total amount. P in dollars. Salem will pay for N tickets. What does 12 represent in the equation? So take a look at these answers here and see if any of them stand out to you as far as what the correct answer could be.
The Y axis.
Yeah, but that's not here.
Okay, well, like
That's right. It is that, and
$12.
that's yeah. So which of these is maybe make it says that or
Um, um,
are
12
there
is
any?
probably the service fee.
Agreed. Agreed. It's definitely like a service fee. So which one is
And
that?
uh, B.
Good. So maybe you used your sort of your knowledge of when you buy stuff and there's always that irritating, you know, service fee. I mean, I called it a convenience fee at one point. Yeah, it's annoying, right? Like, what is the price? Well, but you can see this time you actually did have to go back. You did have to actually go back and like figure out, well, what is it referring to? Um, if maybe once you knew that it was about buying tickets, you could stop there. But sometimes you do have to go back, and that's okay. That's totally okay here. All right. But you just now you know what you're looking for. So here's a new problem. When you read the call to action, when you read the thing that you're actually trying to find, which in this problem it says, which of the following is the closest percentage of participants who gave a rating of 5? We now know to go back to the beginning, which could be this data set, could be these words here. Okay. Which of the following is the closest to the percentage of participants who gave a rating of 5? All right. So what I see here is a data set. Do you think reading any of this will help?
Nope.
Nope. So you should not read it and try to answer the question from there.
Hmm. Oh wait. B.
B. How did you get B?
Because I calculated it using the same way you calculate your grade.
Okay, tell me how you calculate your grade.
Uh, well, it's kind of like if you got like a 35 out of 42 on a test or whatever, you just divide 35. Wait,
So what two numbers did you
30,
divide?
Well, I just saw there was 2 5 ratings.
Okay, out of
And so I divided that by the total amount, which was 11, and I got 18%.
perfect. Now it does say 11 right there. So if you didn't want to count, reading one word helps, or if you counted them all, that's fine too. But yeah, it's about 18%. Good. Okay. So we're getting to the point here in the lesson where it's really up to you now. Like I'm going to put some problems in front of you. I recommend that you use this strategy. It will save you time, but you have to use the strategy. You have to practice, which means you have to really try to not read from the top, which I know is really hard to do. Like we've been told our whole lives, like start from the top, don't skip steps. But this test is about saving you time. And to do this test better than you've done it in the past, you do need to save time. So I would strongly recommend you try this strategy in the next couple of questions that I put up in front of you. So I'd like you to try this question, and I want you to let me know if there's anything that's unclear or you're not sure about as you do it. And go ahead and get started on that, please.
Um, 48.8.
Okay. How much time do you think that question took you?
40 seconds. I don't know.
Yeah, you just under a minute. And that's really good. Really good. And let me just double check if that is the correct answer. It is. Any questions on how to do that?
Uh, yeah. How do you do it?
Well, wait a second. You got the right answer. How did you get the right answer?
I just looked at the low temperatures and kind of just guess
Yeah,
on
we
which
don't want to guess. So no more
one
guessing. Just
that's
if you're going to guess, say, hey, Matthew, I have no idea how to do this. Like I don't, the guessing is not a good strategy. Guessing is not allowed at this point. We'll talk about when you should guess, but this is not a good one. This is asking for the mean or the average.
uh
Do you remember the formula for average?
nope.
Okay. So the average is when you add up all the numbers. Why am I adding up the bottom row instead of the top row?
As we're going for the average low temperature.
Exactly. Now, if you put this in your calculator, you have to be careful. You have to first add up all the numbers in the top, then divide by the number of numbers.
Oh, okay.
So go ahead and try that in your calculator, please. Make sure you actually get the right answer.
Yep. Well, it says 48.6, but whatever.
That means you probably did not enter one of the numbers incorrectly.
Maybe.
So that it matters. Like if you were playing
Yeah. No,
with your friend and you're off by, you guys aren't on the same beat, it's a problem.
I put it incorrectly. Yeah. I put parentheses 48 plus 37
There it
plus
is. It's 49.
wait, what?
49. You said 48.
What the
48.5 is rounded up to 49 votes.
true. I hear you. All right, whatever.
All right, it seems like a small thing, but like the answers are only 2/10 apart. So if you put in a different number here, you could potentially get the wrong answer and think you were right. And this is not a difficult question. This is one where the average is pretty basic. You add them up, divide by the number of numbers. You're allowed to use a calculator. Like you have to get this one right. This is the kind of problem you can absolutely do.
Yeah.
All right, let's try a new problem here. Totally new problem here. Nope, not that one. Let me grab, that's not new. Here's the new problem. All right, again, I recommend reading the call to action first. Go ahead and give that a try, please.
Uh, 140.
How confident are you in your answer?
90% sure.
All right, you are correct and very quick, under 30 seconds to do that one. So it looks like she starts her lunch there and
Yeah.
stops her lunch there. And you're sort of estimating, it's somewhere between 1 and 2. It's closer to 2 than 1. That's the only reasonable answer there. We assume reasonably that she's not moving. It says she stopped. So if you were to go back after you read the call to action, you might might want to do that, or you might just go right to the graph. But you know what you're looking for. Like if the problem said, another problem would say, when did Marilyn begin her descent back to the campsite? That's around 2 o'clock. Around 2 o'clock, she's heading back.
Yeah.
So that's why it's important to read this call to action first. That way, um, okay, like what am I even looking for? Now, I kind of alluded to this earlier. Does this strategy always work?
Um, I mean, I guess technically it probably doesn't.
Nothing works 100%. Nothing's going to give you 100% on this test. They're strategies. They're like approaches. There's never going to be one size fits all for this. And that's why there's a bunch of them that you have to learn or consider. And there are always counterexamples to this. Okay. I want to just put one in front of you before we move on to a math content area. So here's a new problem where the strategy actually does not work. It's not meant to detract you or deter you from using it. It's meant to emphasize that just to be careful. So it says, what is the probability, the nearest hundredth, of selecting a school in San Diego County? So if you go back and look here, all right, San Diego County, there's 854 in San Diego County at 3,241. Could you calculate that for us, please? You have an answer for me? Maybe you are muted.
No. Two or one. Um, hmm. Again, I'm not getting any.
I just want the value. This is wrong. What we're doing is wrong, but I want to show you that. Like you do it
Oh,
and you don't get a number that's in here. And that should bother you. Like it really should. You should say that's not there. And you can't say, well, it's 0.28. Like maybe that's correct, but if I'm writing the test, I'm putting 0.26 down and the correct answer. So, like I said, the strategy doesn't always work. Like sometimes you do have to go back and read, and it says a public middle school will be selected at random from the 2 counties. Okay. So that means we're actually only interested in this row right here. What is the probability to the nearest hundredth selecting a school in San Diego County? So there's 165 in San Diego County out of 587 middle schools. This time when you calculate it, you do get 0.28. And you could sit here and say, hey, Matthew, I would have just guessed. I would have just went over there and said that one. That's fine, but that would not be the right strategy to use. That doesn't always work. Like that's way worse to just make that mistake, because that's something that you will see test test questions do. They'll put the wrong answer in the answer space. All right. Any questions, thoughts on that before we proceed?
No.
Okay. All right. So I do have a bunch more questions here that we can do. Um, I think it would be good for you to do these. I'm going to time you. Don't rush though. Don't guess. I'm going to let you know when about a minute is up, just so you know, hey, the clock is it's ticking there.
7.
We're good. That is correct. Under 30 seconds. All right. So I'm noticing a pattern here with you. The ones that are numerical, you're doing really well on. The ones that are a little bit more of the written sentencey phrases, a little bit more of a struggle with. So give this one a try, please.
Um. Oh. The A.
Are you guessing?
No.
Okay. How do you know it's A?
I mean, kind of makes sense because for on the left there it says is total like charges or dollars, and that seems to go up with the hours. So
With
I'm figuring that's just an hourly rate. So
yes. Yeah. Okay. All right, very good. All right. Now this next question is the most difficult one by the perception of it to start. It is not a difficult question. Please use the strategy and try not to overthink this, because they look difficult, but they're not meant to be.
um 18.
Okay. How did you come up with that?
18's in between 12 and 24.
Okay, but like also in between 15 and 21. So I mean, like why 12 and why 24? Like I need more information than that, because it feels like a guess the way you just said that. Like, what other reasoning are you using for this?
I mean, look at it. It's the only right answer. It's in between on the right for the yards. It only goes 12, 24, 36, 48. And 18 is the only number out of those four choice sets in between 12 and 24.
Okay. What does a head start mean? What does that mean?
It's just the point at which you start at. Well, like in a race, I mean, it'd be
Okay,
like
so
if you gave
where
me
is
5 seconds to run before you start running.
so it could be time. Could it also be distance?
Yeah,
Okay, what is Paul starting at? What's his distance? Paul at
0.
starting at, and what is Mark starting at?
18.
Okay, 18 minus 0 is 18. Okay, like the mistake, because and they probably don't use this question anymore because of what you just did, because that's what it is. But let's just say someone started there and someone started there. What would the head start be in that example in red?
24.
36 minus 12, which is 24. You could again argue that 24 is between them, but that's okay. All right, good job. Really, really good job. Okay, so here is the summary of what we just did. And really important to just like say, okay, what did we actually just learn today? We learned that you read the call to action first. Okay. Then you decide if you need to go back and read more. And because you don't know until you read it. We talked about this, and this is true of every strategy I teach you. Does this strategy always work? You will get the same answer to all the strategies. No, it doesn't always work, but it worked a lot of the time. And that's the point. No strategy will work for every problem. But it leads to the second taking strategy. We actually saw it a bit today, but we'll dive into that next week. So with the rest of the time here, it's always good for us to just solve problems, just solve, solve, solve. And I'm gonna put some problems in front of you that may not be too difficult, but they're kind of related to what we were doing today. And then we'll talk about that. Now this is not these are not like read the call to action first. They're just questions. You can try the strategy. Um, we're just looking at more of a math content area now. There's some questions that you might see on the test. So go ahead and give this one a try, please.
Um, A.
Okay. Yeah. Are you confident in your answer or not?
Um, I mean, my two guesses are, well, not guesses, but like two choices are A and B. But I think because the one I did earlier, I'm going with A.
All right. So we're solving for which variable?
Um, R.
R. So you're going to divide both sides by T. So you're looking for the one that's D over T,
Okay.
which is A. Good. Okay. Now sometimes they don't give you the formula here. It says a rectangle has perimeter P, length L, and width W. So the picture of this would look something like the following. This is L, this is W. Could you give me the equation for perimeter based on this?
Um, that is just length times width.
That's area. Area is length times width. Perimeter is a walk around. You want to walk all the way around the outside.
Do you add all sides?
Yes. What is the result of adding all the sides?
Well, the perimeter.
Okay. And can you give me the equation of the perimeter here in terms of L and W? Like for
Uh,
like, forget about the question. I'm not interested in the question anymore. I'm just interested in what's the perimeter.
L plus W plus L plus W. I don't know.
Yes, yes. So the opposite sides are congruent. What does this reduce to? What does this simplify to?
L squared plus W squared.
Okay, when you add them together, you don't square. That's when you multiply.
Or
So you got one L and one L, one W and one W.
D.
You have two L's plus two W's.
Right.
Okay, so let's try another one here. Let's say I give you something like this, and I tell you that these are congruent, and this is 4x plus y. This is 3x, and this is 6x plus 2y. Could you calculate the perimeter for us, please?
Uh, you want me to?
If
You
you
want me
don't
to
understand, if you don't understand, just the way that you got to communicate, you got to say, "Hey, I don't understand anything you're saying. You're speaking Chinese. You got to tell me. You got to give me some feedback. Like, hey, Matthew, I don't understand, or I don't get it."
what do you want me to do?
Okay, the perimeter is a walk around. Like, imagine you're standing here, and you're gonna walk all the way around. So, like you said, you're adding up all the sides. Do you know the length of this first side? Imagine you're going to the right first. Do you know the length of this side?
6x plus 2y.
6x plus 2y. Then you get to you're over here now. Do you know the length of this one?
4x plus y.
Okay. Then you get down here.
3x
Okay.
and 3x again and 4x
Nope.
plus y.
So this is not 3x. What is this one congruent to? What does this little symbol mean?
4x plus y.
Yes. So if you didn't draw this down, I know you don't have this in front of you. You would on the test. You have to put this in front of you. Okay. Now you've got to add these up. You got to combine like terms. You've got to combine all the x's and then all the y's.
Uh, 21x plus 8y.
Actually, I put an extra y in here that I didn't mean to.
Uh,
So it's 2y plus y plus y plus y. What does that add up to?
5.
5y. Okay, so let's try another one here. Let's say the perimeter of this thing, let's say this is 8x minus 3, and this is 2y plus 5. Could you calculate the perimeter of this for us, please? And this is a rectangle.
Sixteen x minus 6.
Give me your final answer.
Um, 16x minus 6 plus 4y plus 10.
Okay, do any of those combine?
The 10 and -6.
Okay, so what is the final answer?
Um, 16x. Wait. 16x plus 4 plus 4y.
Good, very good. All right, I think we can get one more question in, going back to problems that we were doing earlier. Definitely is a good one to use that call to action first on. So take a look at this, give this a try here. Do you have an answer for me?
Um,
Which variable are we solving for?
and is it
Says you're solving for L, and all the answers are L
oh,
equals.
is it, oh wait,
So you're gonna divide both sides by 7H.
C?
So C, there you go. All right, we're gonna stop there for today. Oops, I don't mean to do that. All right.